Hello students, let us discuss what is the difference between the CBSE questions and the NEET questions. See, if you look at the syllabus, as far as syllabus is concerned, syllabus is same in chemistry for CBSE as well as for the NEET examination. The only difference comes in the framing of the question. And as a student, for you, all topics, all chapters are equally important because there is no weightage given to the different chapters in the NEET exam. They may take 2-3 questions just from the biomolecule and nothing from the alcohol or electrochemistry or organic chemistry, 1 or 2 chapters. So as a student, you give equal importance to all chapters, equal importance to all topics. The topics which you feel they are not important, you give more importance. Because the aim of the entrance examination is how to eliminate the students, not to select the students. Selection is difficult, elimination is easy. And the aim of the CBSE is to pass each and every student. So I'll discuss some questions, how they frame the question in CBSE and how they twist the question for the NEET exam. For example, if in CBSE we give a question, write the Lewis dot structure of nitrogen. Right? What is the Lewis dot structure of nitrogen? Lewis dot structure of a nitrogen atom. So since nitrogen has 5 valence electrons and the student can put all 5 dots anywhere around the nitrogen like this. But this is not the correct way to show the Lewis dot structure of nitrogen. Now, if the question is framed in the NEET exam, we frame the question like this: which of the following is the correct Lewis dot structure of nitrogen? You will be given 4 options, like one of the option is this. You have 5 valence electrons, the first option. Second option is this. Third option is this. Or fourth option is all are correct. So in this case, the correct option is the option C. So if you look at the electronic configuration of nitrogen, nitrogen has an electronic configuration of helium 2s2 and 2p3, in which all 3 electrons are unpaired. So when you draw the Lewis dot structure, you have to show 3 electrons as single electrons and 1 electron pair. So C is the correct structure for nitrogen. So you have to be very careful. You try to relate the Lewis dot structure with the electronic configuration. We take one more example. Now suppose you are given cobalt 3+. Now when we frame the question in CBSE, we'll give the question, okay, write the electronic configuration. Write the electronic configuration. Okay, and the student will write the configuration of cobalt 3+ as this: argon 3d6. That's all. But when we frame the question from the NEET exam point of view, we frame the question like this: how many orbitals in cobalt 3+ are filled with 1 or more than 1 electron? 1 or more than 1 electron. So in this case, you have to write the expanded electronic configuration of cobalt 3+ like this. It's a 1s2, 2s2, 2p6, then we write 3s2, then we write 3p6, and then we write 3d6. Now to calculate how many orbitals are filled with 1 or more than 1 electron, you look at the boxes. For 1s, we draw 1 box, so you have 2 electrons. For 2s, again we draw 1 box, you have 2 electrons. For 2p, we draw 3 boxes, 2px, 2py, 2pz. So we have 2 electrons in each box in each orbital. Then 3s orbital, you have 2 electrons. For 3p also, we draw 3 boxes, 3px, 3py, 3pz. So each box is filled with electron. Now for D, you have to draw 5 boxes, and each box in this case is filled with one or more than one electron. So now you count how many boxes, each box represents the atomic orbital. See how many boxes are filled with one or more than one electron. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and plus 5, 14. So there are 14 orbitals present in cobalt 3 plus, which are filled with one or more than one electron, right? So this is the way we differentiate the entrance exam and the CBSE. But in both the cases, if you see, the configuration is very, very important. Without configuration, you can't answer this question. Now we take one more question. For example, you are given BrF5. This is a molecule given. Now in CBSE, we ask what is the shape of BrF5 molecule and what is the hybridization of bromine. It's a direct question. Hybridization of bromine in BrF5. So in this case, what will happen? The student will write that the bromine is sp3d2 hybridized, and the shape of BrF5 molecule is square pyramid. But when we take the same BrF5 molecule from the entrance exam point of view, we frame the question like this: how many 90-degree bond angles present in BrF5? So first of all, you should know what is the shape of BrF5 molecule. Since it's a square pyramid with one lone pair of electron present, so this is the shape of the BrF5 molecule. And there's one lone pair on bromine. And you know, lone pair has two effects. It affects the shape. That's why the shape is square pyramid and not octahedral. And lone pair also affects the bond angle. In octahedral, without a lone pair, if all electron pairs are bond pairs, the bond angle is exactly 90 degrees. But since one lone pair has come, it increases the repulsion between the lone pair and bond pair. As a result, not a single angle in this case is 90 degrees. So due to lone pair of electrons, there is 0 90-degree bond angle in BrF5. So the answer will be 0. So this is the way we differentiate the question. So we are taking BrF5 molecule, but we are framing different question from the different exams. We take one more example. The question is N2 is changing into N2 plus and O2 is changing into O2 plus. How does the bond order changes in this reaction? Now when the question is framed from the CBSE point of view, we simply give a question, okay, write the electronic configuration of nitrogen molecule and calculate the bond order. Now the question is, how does the bond order changes in these two reactions? Now if you look at, in the case of nitrogen, the last electrons are in the bonding molecular orbital. Bonding molecular orbital. And N2 molecule has a bond order equals to 3. And in O2 molecule, the last electrons are in the anti-bonding molecular orbital. Anti-bonding molecular orbital. And O2 molecule has a bond order equals to 2. But remember, anti-bonding molecular orbital makes the molecule unstable. So if you remove electron from the anti-bonding, the stability will increase, bond order will also increase. So if you're given bonding molecular orbital, anti-bonding molecular orbital, the bond order increases by 0.5 when you add electron to bonding molecular orbital and removal of electron from the anti-bonding. Similarly, the bond order decreases by 0.5 if we remove electron from the bonding and adding electron to the anti-bonding. So in N2 molecule, since the last electron is in the bonding molecular orbital and the removal of electron from the bonding will decrease the bond order by 0.5. So this N2 plus has a bond order of 2.5. Now O2 molecule has a bond order of 2.0, and in O2 molecule the last electron is in the anti-bonding, and when you remove this the stability will increase. So the bond order will increase by 0.5, so it becomes 2.5. So in N2 to N2 plus the bond order decreases. In O2 to O2 plus the bond order increases. So the framing of the question is different, although the concept is same. So this is the difference between the CBSE and the NEET examination. So syllabus is same, only the framing of the question is different. So you look at the statement, look at the question from the analytical point of view. Thank you very much.